There it is.
Sorry.
Okay, sorry. Now, x, we'll say plus 3 equals 9. So there's an example. So the solution of this is 6. Everybody see that? So that's what you're going to be doing. You're going to make them up. Actually, you can do it on the whiteboard. Sorry. You can use a whiteboard. And you're to make an equation, you can use multiplication, subtraction, division, as long as the solution is 6.
Oh, on a whiteboard?
Yeah, on your whiteboard, I'm sorry.
Be creative. As many as you can do. Subscribe. Yeah, subscribe because I can change the name of the YouTube channel once I have 100 subscribers.
What are you gonna change it to?
Just like youtube.com/mathwithmrs.c. Like easy, something easy. Right now it's like
How many subscribers do you
like
have?
7. Alright, keep going.
You have 8 because I subscribed.
Alright, keep going as much as you can on that whiteboard. Wait, now see here, x divided by 2 is 6 and x is 12. We need whatever you're doing for x to end up being 6. Good through beyond.
Perfect. Okay, so does anybody want to share one?
2x plus 15 minus 12 equals 15.
2x plus 15 minus 12
Equals 15.
equals 15. Good, so I like how there's a lot of steps in there. Does anybody have another one they want to share with us?
X equals the square root of 36.
What's it?
X
Square
equals,
root of 36
No,
is
don't
6.
do it that way. Do the other one, the top one.
X squared equals 36.
X squared equals 36.
there we go.
The only reason is when you're here, that's actually not inclusion. That's
X
just
squared
what
equals
we're
36.
This is
Yeah.
X squared
Go ahead.
equals 36.
Okay, I get it.
Because a number times itself gives us 36. 6 times 6 is 36.
2 parentheses x plus 2 parentheses equals 16.
Love that one.
Awesome. Yes.
Okay. 282 divided by x equals 42.
282 divided by x equals what?
47.
47.
That's wrong?
That's probably right. Let's see, 6 times 40 is 240. And 6 times 7 is 42. No, you're good. I
like how you use division like that. Awesome. Yeah.
1.5 parentheses x plus 5.
I'm sorry, 1/2. Oh.
No, half.
Half.
Parentheses
One half.
x plus 5 equals 5.5.
Equals 5.
Wait, 5 half or 5 and?
5.5.
5.5. Okay.
What happened to x plus 3 equals 9? Look, you guys are so creative.
Yeah, you guys are great.
That's awesome. Yeah.
What else do we have? I know there's more out there. I was walking out and I saw a bunch.
3x equals 18.
It's a great one.
3x equals 18. Awesome. Anybody else? Yes? Yes, go. What?
4x.
4x equals 24. Awesome. Another one? Go ahead.
4. I'm gonna steal from someone. Parentheses. 2x plus 4.
2x plus 4.
Parentheses. 32. This is only guess. This is guessing.
Don't guess.
Don't guess, because you want it to equal 6. You want to make sure it equals 6.
Are you sure that equals 6?
I just added that one together. So
So you were putting a couple equations together.
We're trying for mine. Okay. Do we know if that one works?
it should.
How do you know?
Wait.
How can we check if it works?
We answer
Plug in
this.
6.
Okay, so you can solve it. What's another way?
Ayana had a good idea.
Ayana?
Plug in 6.
Plug in 6. Perfect. So we know that x equals 6, or we want x equals 6. So you can plug in 6 to see if it works. So 2 times 6 is 12, plus 4, 16 times 4.
Does 64 equal 32?
Is that a true statement?
No.
No. Alright,
So
so
the answer is 6.
that's awesome. I'm actually glad you did that because that's where I wanted to go with this. So that's how you can check. And then we know that this is not equal to 2, so that does not work. That's okay. Good effort. I'm glad that you were trying to put different things together because he was trying to put multiple steps in there, multiplication, subtraction, everything, which you all did really well. So good job. Okay. So now I'm gonna hand out, or not hand out, 2 different students' work. What are their names? Amy and
Laura.
Laura. Okay. So what you're gonna do is take turns to work through their work and like explain it to your partner. See if you understand what they're doing. Explain to them what they did. So you're gonna turn to your partner and explain. No, this is what Amy did. She did this, and then she did this for the next step, and so on. So listen carefully to each other's explanations and ask questions if you're not quite sure. Okay? So once you're both satisfied with the explanations, correct any mistakes, because it's not perfect, they're not perfectly done. Everybody makes mistakes, there might be a mistake in there somewhere. So correct any mistakes, and then, so please talk with your groups, and then we'll wrap it up. Alright?
And remember what we said, when you can find an error and fix it, that's a really high level of understanding, which is why we like to do that. This is an example of that.
Well, we're just gonna take it and we both be partners. It was in the middle, like touching in this.
It was right here. Yes, it was. Really?
I know. That's bad enough. Alright.
Was right.
It looked like right.
Alright. X equals 2, 8. Okay, that's right. X divided 8 divided by 2 is 4. X plus 2, 8 divided by 2 equals 4 minus 2 equals 3. Oh, that's right. She's right.
Alright, what about one?
She's using percentages. Alright, X equals 6. X minus 2 whole square, that's right. X 4 divided by 8. Oh, wait. Wait, she subtracted 2.
So this she's showing Laura is showing you what she did for your stuff. So let's not start with an X equals 6 and then here.
Right.
Subtract 2.
So that equals 4.
She's just saying, let's start right there.
Wait, no.
Here.
7 over 4.
Okay.
What the heck? No, that's not right.
7 over 4. Why did you
That's why we
say
got
those?
here.
What is this?
That's why we got added on. We could just put you wrong. Alright, plus 2, plus 1, 3. 7. That's 7. Wait, you told me.
Wait, is this SCX?
F 5 X plus 1. This equals 7. This right here equals 7. This
I can't read this, but it looks like 5CX plus 1.
Okay, guys. So. Alright, so we're gonna go back up to the front. We're gonna look at Amy's work first. Can someone explain to me what Amy did in this first step right here? Yes.
add 2.
She added 2. And if you notice, she didn't just add 2 here. She also added 2 here, right? Why'd she do that? Why did she do that?
What'd you say?
If you notice, she didn't just add 2 on this side, she also added 2 here. Why?
What you mean she did?
From this step to this step.
Yes.
Because we have to keep the equation balanced by doing it on both, by whatever we do to one side of the equation, we have to do on the other. Good. Okay, so somebody tell me what she did from this next step, from here to here. Giselle?
Oh no, 8. So then she did 6 plus 3 is 8. Divided by 2 is 4.
So she divided by 2?
Yes.
Okay, so here she divided by 2. She divided by 2 over here, and then she also divided by 2 over here, right? Okay, so now what did she do? Now what happened?
Subtracted the problem by 1.
What?
Subtracted the problem by 1.
She subtracted the problem by 1. See, if you notice, she subtracted this entire term, that's one term. And she subtracted that whole thing by 1. What she didn't do, which she would have been wrong if she did this, she didn't go like this.
I'll go back.
Sorry.
PowerPoint's very sensitive on the smart board.
So she. didn't do that. That would have been wrong. Why? Why do you think that would have been wrong?
Because you're dividing 2 by x plus 2.
Yeah, so we're dividing 2 just by x plus 2. And then, from that point, we're subtracting 1 by the whole, this entire thing is being subtracted by 1. Not just the 2. In this case, it would have been x plus 2 minus 1 would have been x plus 1, all divided by 2. Right? But that's not what we want. We want to subtract the entire side of that equation by 1. And then we want to do the same to the other side. Alright. So, what did you do here? What did you do to get from here to here? Anybody else? Sorry. You guys both start again. Yeah. She multiplied 3. Good. She multiplied 3. She multiplied this side of the equation by 3 and this side of the equation by 3. Notice that she used parentheses and multiplied the entire thing, right? She didn't just put a 3 right here, because that would have just multiplied this. And then what you do to one entire side of the equation, you need to do to the other entire side of the equation. Okay? If she did that, she would have left out this minus 1, and she would have had to multiply that as well, right? We need to keep our equation balanced. So did she make any mistakes?
No.
No. Good. Alright, so now we're going to take a look at Laura's work. Okay, so this is what Laura did. She started with x equals 6, and she actually showed you her steps, exactly what she did. That's what those arrows were. So first she subtracted 2 from both sides. Did she make any mistakes there?
No.
No, she took x, she subtracted 2 from it, and then she took 6 on this side of the equal sign and subtracted 2 from it, got 4. Good. So this next step, she's telling us that she divided 4. Did she make any mistakes there? No, she divided the entire side of the equation by 4, right? And then she divided the entire this side of the equation by 4. What if she did this?
You're good, sorry.
Is that right? No, that's not right, because she needs to divide the entire side of the equation. not
Who just started to say like 6 minus, who did that? Someone was saying it. Someone actually, was that you? You actually, I love how you tried to figure it out. Instead of trying to solve the equation, you just substituted in a 6 for x. And I heard you say like 6 minus, and like you kind of trailed off because you knew it didn't make sense. That was a good way to find the mistake.
Awesome. All right. So she did that right. We agree? All right. So now she added 3 to both sides, right? Did she do that right? No.
No.
That's what
All right. So what did she do? What did she do wrong?
She did.
Why is she wrong?
she didn't
Leah?
add
She
3.
did that.
Well, she did. She went from -2 to 1.
So look, -2 plus 3 equals 1,
Oh.
right?
Oh.
Doesn't that equal 1?
Oh, yeah.
So why are you saying no? Why is she wrong?
What the? What?
Okay, so you have to do the whole thing first, then you have to add the
Perfect. So you have to add 3 to everything on this side, not just up here. You have to add 3 to that entire thing, right there. Okay? So what would have been correct? So this side of the equation is correct, right? 1 plus 3 is 4. We know that. So this side of the equal sign is right. What would have been correct on this side of the equal sign?
Who can explain to us what would have been right?
Okay.
What would have been right if she needed to add 3?
X plus 1 over 4 plus 3.
The entire thing plus 3.
Anyone want to disagree? Lose?
It's not plus, right? It's -2.
Correct. Go back, Mortimer. One previous step. The expression is x minus 2 over 4. You want to add 3 to that whole thing.
So minus 2. So this is the equation, and we're adding 3 to both sides. and that's what we should get, right? We're not just adding 3 to the numerator over here, we have to add it to the entire side of the equation. Good. So then from there, she couldn't have been right in the next step, right? So at the end, if we put in a 6 for x here, if we substituted the 6 for x, would that have worked out? No. Did anyone try to do that? You did? Awesome. What did you get?
35.
35 over 4. So that's definitely not 6.
At that last move where she multiplied by 5 and ends up with 5 parentheses x plus 1 over 4, did she do that step right?
No.
Why?
To do with everything.
Did she?
No, she only did.
Look at the expression there on the left side of the equal sign. Did she multiply that whole thing by 5?
Yes, no.
If you multiply a fraction, right, and this, we need to go over this because you may not see it. 5 times, and we're just pretending like x minus, or x plus 1 over 4 was correct, right?
Oh,
Alright.
I
If I was gonna multiply this, right, what would I get?
you would get, oh,
Think about how you multiply a fraction. Is that correct, the way she multiplied that?
I kind of, yeah.
Yeah, that is right. And I know it might not look right because it doesn't look like this 5 is multiplying by that entire expression, but it is. Because you multiplied 5 over 1. So there's nothing in that denominator because it's a 1. So this is actually correct. When you distribute it would be 5x plus 5. Sorry, I just wanted to point that out because that may not jump out at you all as being correct.
So good job, everyone. We all found that mistake, right?
Yes.
Okay.
Sorry.
Okay. So now every x in an equation has like a story, right? So here's Amy's equation. I want you to solve this on your whiteboard.
There should be a little rag. No. Oh. Oh yeah, no, just show your steps.
We just want to see your exact steps, what the steps that you took to solve this.
Think about what you're doing. First I did this, then I did this, then I did this.
Wait, what's that?
Solve it, find out.
Oh.
Alright, so that's not what we want to do. I don't know, is it? Didn't know what.
Which Carolina? I'll be learning about this today.
What?
I'll be learning about this today. Solving the-
So we want to, so we know, we watched her build this equation, right? So we know what x is because we watched her start from x equals 6 and build this equation. So pretend that you don't know that x equals 6 and solve this equation the way you would if you had no idea that x was 6. Okay?
I'm gonna try to do it. Multiply 2. You know what? I'm gonna. What do we do with the dead markers?
If you didn't know that X was 6, how would you solve it?
I did it right.
Yeah.
I think I did it right. I think I did it right.
Okay, so we're gonna go ahead, got started. What did you do first? Someone tell me what they did first? Yeah. It's divided the 3 on this side, and then the 3 on this side, because it took away the 3 on this side, and made it a whole, made it 3 over 3. Made it a big 1, right? And then he divided 3 on this side. Okay, good.
What was the issue for those of you that tried to distribute? Because a few of you tried to distribute the 3. What happened with the expression on the left side? Did it get messy? Yeah, it gets pretty messy. If you look at Amy's steps when she built the equation, what was the last thing she did when she created the equation? Look at the paper that you have. What was the last thing Amy did when she created her equation? She multiplied both sides by 3. So is it off or weird that your first step may have been to divide both sides by 3? Well, that kind of makes sense. You're starting to undo exactly what she did.
So go ahead and compare, take a look and compare the rest of her steps with your step that you took to solve.
Wait, so did I?
What you should be starting to notice is exactly what Mrs. Paramano said. We're undoing her steps. Take a look at her steps. The first thing she did the last thing she did was multiply by 3. So the first thing we're gonna do is divide by 3. So we're doing it in reverse order. We're doing the opposite operation in reverse order,
Well,
right?
Inverse
Mind
operations.
it's like inversing the inverse operation.
Exactly. So she multiplied by 3 first, we're gonna divide by 3 first. Alright, and then the second to last step she did was subtracted 1. We're gonna add 1. She multiplied by 2 before that. She divided by 2 before that. So we did the inverse operation and multiplied by 2. Right? Does everyone see how we're doing this?
Yeah.
Does anyone have any questions on this? No? Okay. Good. So everyone sees the relationship between those? Isn't that kind of cool?
No, I have to.
Yeah.
So when you're dividing by the first part is you divide by 3. Like
Uh-huh.
how do you you divide the whole term like
You have to divide. So this is, let's pretend for a minute that this entire thing is just an x, what would you do then?
Maybe.
What would you do? So now it reads 3x equals 9,
You would divide.
right? Divide by 3, and divide by 3. So that's it. This is one term. This is one term. It's multiplied 3 times this. So you have to divide 3 by the whole thing, the entire side.
Okay.
Okay?
Because that expression there with the 3 in the parentheses, that means you have 3 of everything inside. If you divide by 3, then you only have 1 of everything inside. So nothing inside has changed when you divide that whole side by 3. See that?
Yeah, I understand now.
Understand? Okay. Awesome.
Oh, there it is.
Okay. So here's another student, Rob.
Right.
This is his work. So he wanted to build an equation, start by x equals 6, right? And this is what he did to build the equation. So what steps would you take to solve Rob's equation? Just by looking at it really quickly, what steps would you take? I'll give you a minute. You don't have to write it down, we're just gonna discuss it. Anybody have any idea? I need to know. You raising your hand? Sure. Yeah, okay. So what steps would you take to solve this? So we're starting with it right here, right? This is our equation. Alright, so first you would multiply by 5. And then that would take care of nothing. Alright, so then 2 multiplied by 5. Right? Yeah. That was good. And then what? And then what would you do? Are you ready? First we're multiplying by 5.
Lily, what do you think?
Okay, so now you're adding 1. You're getting there. Now what? Subtract 3. Okay. Now what? Leah? Divide 2.
What did we do?
Three.
You just did the opposite, right, of what happened to the variable, right? And we did it in order, only because we know that that's exactly what happened to the variable.
Okay.
So, I'm sorry.
Oh, sorry.
When we talk in class about identify first what happened to the variable, that has you in class figuring out this, so that from the equation you can then work backwards.
So, if you look at this equation, so now take this and write it down. 2x plus 2 all divided by 5 equals 2.8. Is there another way that you might have solved that? Do you think you had to take every step and reverse it and do the inverse operation of it? Do you think you had to do that? If you're just looking, pretend like you don't know how Rob built this. And you're just looking at this. Think about the steps you might have taken.
Equals 2.8.
Is that the only way?
Probably not.
All right.
Mortimer's onto us. Probably not. Look at any of the steps. Would you have done, or could you have done something different at any of the steps?
I was thinking maybe you could do the inverse of adding 2 first, maybe.
All right. First, the very first thing you would do would add 2.
Well, not that I would do it, like maybe it could be a different way that somebody else could do it.
Can we do that?
Actually, gonna come over here.
He's saying that if you see that like adding 2, then maybe you can just like do the opposite of that or subtract 2 from both sides to start.
So can we subtract 2 from both sides right now? Is that okay? Is that allowed? Yeah, you can? Well, yeah, you can do anything both sides.
No.
But would that help us?
Is that one step closer to isolating our variable?
So the first thing, what's the first thing you would do? Right now. Pretend like we don't know how Rob got this equation. We have no idea. What's the first thing you would do right now? Multiply by 5. So we would multiply by 5 over here, multiply by 5 over here. Good. And then this gives us a big 1, right? Because it's 5 over 5. Alright, and then that gives us what? 14. Okay. Alright, so now we're going to bring this down. 2x plus 2 equals 14. What would you do next?
Do we have to subtract 2?
I'll divide by 2.
You could divide by 2.
Divide what by 2? Just the 2? Okay, just the 2x? Go ahead.
No, everything.
Everything, the whole
Everything on
side.
the side you could divide by 2.
Thank you, sorry, Mom.
Is there, would somebody do this a different way? Would you have started another way from this step? What would you have done?
I probably wouldn't really do this. I probably would just solve it from here.
Oh, like in your head. Okay, cool. But what about, like, alright, so besides in your head, if this is a little harder to do in your head, what would you do from there? And if you didn't want to divide by 2, which you can do, that's great. That's another way too. What would you do? You have 2x plus 2 equals 14. What would you do? You want to get the x by itself on one side of the equation side, on one side of the equation or one side of the equal sign. Subtract 2. Okay, so look at what Rob did next. He subtracted 1, and then he added 3. So that's the same thing as subtracting 2. He just took an extra step, right? Alright, so now we subtract 2, and we have 2x equals 12. Alright, and then what would you do next? So 2x equals 12 up here, sorry. Yes. Now we can divide 2. Alright? Which gives us the same answer, x equals 6. So we took different steps. So that was 3 different ways that we went over. We had Manny's way, he divided the whole side by 2. We could subtract by 2. We could subtract by 1, and then add 1 and then subtract by 3. Okay? Does everybody understand?
Are we following the unraveling of the equation? Because when an equation is complex with like the big parentheses and the fraction mark, you're really just identifying what's happening and undoing it. But these get to be a little bit more complex. Do we all feel like pretty comfortable no matter what the equation looks like? No matter what the equation looks like, of figuring out what's happening to x and then undoing each thing.
Alright, so now I'm handing out a sheet that you're actually going to build your own equations.
You're each going to get one of these. Don't show your partner.
Because eventually, you are going to solve your partner's equation.
So you see how there's like a dashed line with a scissor mark? Just fold it. So like fold it like this. Okay. So that you can see building equations.
So on the top there, that's what you're going to do right now. The top part above the dotted line. You're going to build your own equation. So start with x equals whatever you want it to equal. And then start adding operations. So what you want to do is use 4 different integers and 4 different operations. Yeah, and 4 different operations. Okay, so 4 different integers or constants and 4 different operations.
You don't want it to be, you want it to be challenging. So you don't want it to just be like plus 2, plus 5, plus 6, plus 9. No. Maybe add 3. Then maybe divide the whole thing by 5. Maybe then multiply everything by 1. Like try to make it a little complicated so that when your partner solves it, they have to really prove that they understand how to undo everything.
So after you have your equation, so you just want to double check and make sure you did everything right? So what you want to do is substitute whatever you made x in and make sure it comes out correct. Make sure it's
going to get your end equation on the other side of the sheet, and they have to solve it. So right now, do not show the person next to you, the person that you went over, the Amy and Laura. Don't show them what you're doing, because they're going to solve what you're creating. So it's like a secret.
I wanna make it any harder than that,
So
right?
when you're done doing all this part,
Yep.
you just write your end equation here.
Yeah, exactly, so Mortimer just like, when you have an equation, write it here.
What is these little words?
New steps.
It's that. Like, see how they showed, like, we subtracted 2, like that. Try to use this as a guide. Like, this is what you're doing. And then she started with 6, and she added 2 to both sides, and she divided both sides by 2. See how she did that to get to there? You're doing the same thing. You're whatever you want x to be. Any number. It could be 5, it could be 3. Use integers for your value of x. Like, don't make x 1/4.
Yeah, somebody said
X is an
square root
integer.
of 25, no. Square root of 26, what did you say? Well,
You're gonna
we don't want that.
You're gonna build it from the ground up. Choose a value of x. Any number you want, right? Okay, so you're gonna do something. So both sides. What do you want your first operation? What do you wanna do? Anything. Say you want to like add 3 both sides. So this would become x plus 3 and the other side would become. So then you're gonna build it. You can use this as an example. So like Amy started with 6 and she added 2 to x, so then this became 8. And then she divided this whole side by 2. She did the same here, that's how. And then she took 1 away from both sides, so it became this and then 3. And then she multiplied both sides by 9, so she showed the whole thing you multiply by, or I'm sorry, whole side multiplied by 3 and then so you're gonna build it however you want.
Okay,
So you still have an equation. So let's do I have to do an example.
But it's really easy. What did we do for the last
Hold
one?
on. I don't want that.
I know, but I used all mine.
If you're having a hard time, take a look at the board. I just created an example. I started with a variable. I have an equation, x equals 2. First operation I decided to do was multiply by 4, both sides. So my equation is 4x equals 8. Some of you don't have an equation. You're just doing an expression. You need an equation. Okay? Then my next operation, I'm going to add 8 to both sides. So this becomes 4x plus 8, and this becomes 16. Then I decided to divide both sides by 4. This whole thing divided by 4, and then 16 divided by 4 gives me 4. And then I took 11 away from this whole thing, which is not negative 3. Negative. Use that as a guide for those of you that are having a hard time building. Some of you aren't building equations. You have like only an expression.
no, that's to get your partner, so you can figure out, you found this equation, so write that equation on top here, that's what I'm going to solve it.
What do we do for the last step?
Right, so if this is your operation, And this is what you're doing to both sides. Where's your eraser? That's what you did to both sides, and this would be that. To show that you did that to both sides. And it may not be the first operation you wanna do, because it gets a little messy, but you good. That's what you want.
So I did it right?
So you started here, so what did you do to get here? So that's the starting point.
Bless you.
Okay, so
Bless you. So the operations are what you're writing on the left side, where those lines are, and then the right side, it's every step is the new equation. So you just kind of flip flop your times. So then what would this become if you did this and you made that operation to both sides? Write it down. What both sides? The whole side, both sides. So like what would, sorry. What would this side become? Did that operation. What would that become? See the difference?